All right, let's hear for Akshay and talk about xsNumPy.
Hello, hello. So, okay. All right, I'll get started. If you have any questions, feel free to come on in, okay? So I'll review on myself. So I've been using NumPy for like 6-7 years now. And I was just talking to, but I'm using NumPy all the time, import NumPy as NP, my matplotlib, pyplotplt all the time, but like I never thought like how it works behind the scenes. So, and I wanted to change that, like, how it works. So that's the whole process. That was the whole reason I started this project. I'll start learning about NumPy more properly instead of just using it. So a couple of acceptance criteria for myself were, I'll just use standard libraries. I just want to be in Python because I know Python pretty well. I'll just stick with Python. I don't want to use anything else here. No AI, no ChatGPT whatsoever. If I can't implement something, I'll just leave it be. I don't want to go fancy, implement the whole NumPy stack. It should be pip 8 compliant for some reason. I am a sucker for pip 8 for some bad reason. I just like to have code written and properly maintained. It should be documented, so thank you. So it should be properly documented, so everything should have a good amount of doc strings, which is explainable itself. It should be fully typed, so MyPy, PyWrite, whatever you use, it should be fully supported. And it should be a drop-in replacement for NumPy. What that means is, if you have xsNumPy and NumPy, if you write the same APIs, they should work across the board in the same way. So these were a couple of rules that I put on myself when I was doing this project. So for tonight's agenda, so it's like going to be super, super fast crash course on NumPy, what NumPy is, like just in case some people don't know exactly what it is. I'll write a small code about like how I have built xsNumPy, and we are ChiPy, so try to use Python as much as possible. So that's the whole point. So who are the target audience? So technically, I'll be honest, like it's just me. It's like, if I want to give a talk about what I did, I would like to explain to myself the way I did it so I could improve upon that. But I'm coming there as from a perspective of a software engineer because I say, oh, I do ML engineering, I do AI engineering. So I come from a software engineering background. So what are my strengths, And whatever I have, the amounts of experience that I've gained over the last 7-8 years writing Python, C++ code, how can I use that knowledge to my advantage to build something that I can actually use in practice, And I was talking to someone who was like, hey, I was thinking of writing something like NumPy. And everyone was like, why are you doing that? Like, isn't it already there? What's the point? I was like, yeah, it's like, I don't want to reinvent the wheel, but I want to understand how the actual wheel works. It's stupid, like it's round, so there's nothing there, but I still want to understand the mechanics behind it. So a quick show of hands. So like, how many of you know NumPy? Okay, oh, I wasn't expecting that many, but okay. How many of you know NumPy really well? That's all I wanted to say. So that's the thing, This was the trick question. It's like, oh, I know NumPy. I use NumPy all the time. But like, okay, really? Who are you kidding? So that was the whole thing. So if you want to follow along, like, there's a link here. Go to the repository. There's some like basic code over there. So all you need is Python 3 or higher. As I said, like, no external libraries, nothing that you have to install. So you can just go with Python, like, the standard libraries are enough. Technically, it should work on 3.7, 3.8 also, because since we're just working with Python, there's no reason it shouldn't work. But I have not personally tested that thing on 3.8, 3.9 or something. So I'm not sure, but like 3.10, 3.13 on 3.14 beta, it works just fine on the dev build, sorry. So I want to start with this movie. How many of you seen this one? Okay, good. So if you're not, like, a super premise of this movie is like, it's a 2008-6 kind of movie, starring Brad Pitt and Kate Blanchett. So in this movie, it's a funny movie wherein, like, the main cast, Brad Pitt, is kind of born old. I mean, I know it's kind of stupid, like, to say these two words in the same sentence, but he's kind of born old, and kind of, as he ages, he gets younger. So the whole point was, like, I want to have the same thing. So the cutest case of NumPy NG array. So this is the most oldest, boring like most wrinkly stuff that's there in Python or in NumPy specifically, that's something that I want to explore. And that was my whole point. Instead of just going in NumPy, creating a class, 10 fancy stuff, no. I want to understand how the NumPy ND array works, and I'll go, in that way. So part one, the basics, we'll just learn about a little bit of NumPy just in case a refresher. So NumPy 101, so NumPy, in NumPy, arrays are the first class objects. So you can do array 1 to 3, you can have floating point numbers and everything. You can do the array stuff that's like arithmetics. A lot of people don't know this add operator, so that's the matmul, multiplication, matrix multiplication. It's also called as a dot product. So that's something a lot of machine learning folks do. So matrix multiplication for dot product and stuff. And you can do all sorts of additive operations on NumPy arrays. So another thing is NumPy is super fast. Just in case if you guys don't know, it is kind of in C, C++. It's super fast as compared to what Python can nearly offer us in terms of speed. Python stores references, NumPy does and it stores values in a contiguous memory block coming from C, so that's the thing. And you just SIMD, so single instruction, multiple data, instruction kind of processing pipeline, which kind of does the vector multiplication or vector operations more quickly. So, but that's about NumPy. Any questions so far? If you have any questions, please come on in, okay? But let's talk about xsNumPy, that's a talk about. So this is how it started off, These are the main characters, the main cast in xsNumPy, the data types, shapes or sizes, and what was the one more? Let's see. So the data types. The data type are basically the type of data, In Python, we kind of have very few limited types, like you have ints, floats, strings, lists, tuples. But in NumPy, you have the same variants, but they have the small cousins, I would say. Like you have int16, you have uint16, so 16-bit variations and all the stuff. And that's something I wanted to implement because that gives the NumPy its NumPy powers. The other stuff is, this is how I did it. I use C types. Again, a little bit of cheating, but that's something I had to do. I can't do it just using pure Python. But I'm still in pure Python. I'm not installing anything. So C types, I'm using the C types APIs to kind of mimic the data types that are available out there. Bunch of things in the final. Oh, okay.
What are C types?
So C types is basically, if I want to explain it simply, C type is just a wrapper for abstracting C APIs with Python. Okay, it kind of gives you a lot of under the hood C abstractions, but you don't have to use any headers or anything. You can just use the normal Python C bool, so it will give you the Boolean logics behind it, Boolean objects. So I wrote a bunch of objects just to mimic the different data types that NumPy offers. And C types does it also. I don't have to think about the underlying, the bit shift operations and everything. C types takes care of everything. So the next step was to have shape or sizes. These are how big the array dimension should be. It should be 1 by 10, 2 by 5, whatever shapes you give. So that's the stuff. I was like, okay, how to implement shapes? I was like, oh, okay. It's a tuple of m by n, m by n by k, whatever. I can just get a product and I can see how many elements I have. It's simple code. And finally was tried. So this is the most annoying side character because it's easy to understand, but it was not easy to implement, at least for me. So strides are how much steps you need to move to the next element. So if you don't understand, I'll explain. So strides is if I have an element of size 4, I need to jump, and if it's just one element of size 4, I need to jump one element, but with 4 steps to get there, or I have to jump 4 blocks to get there. So that's about strides. So whole NumPy ND array was built with this primary idea. It will be the primary data structure for xsNumPy. It will do it will lay the foundation of like, the memory efficient behavior or like the abstraction what NumPy offers. And again, pure Python, no C, C++. That's a cheating, but okay, you have to give some time. Now, the few things that NumPy interior has is like the shape, dtype, buffer, offset, and stride. So shapes are like, as I explained, so like the shape, the dimension, how big the NumPy array should be. Data types are like what are the data types of the elements in the in the array. Buffer is like how much pre-allocated memory that you need to give, because since NumPy does these things in the world of C, you have to explain how much block of memory you're going to allocate. So that's where buffer comes in. Offset is like how much you're going to jump from one point to another point if you want to do some operations. So the strides and everything, so that's where like an offset comes in. And strides are like the step size when you kind of need to move. So this was basic. I'll go very quickly with this class. So this is the basic ND array class. So you have the shape. This is this. Shape is basically the size, like how much you need the array to be. And I'm kind of ensuring that it's always tuple, because sometimes people send lists and it kind of affects the whole thing, because the mutability, the Python mutable, because if you see the init or like the function definitions, they are like runtime checks. So I just wanted to make sure and it's not like affecting anything. So I had to make it show that it's a tuple or something. These are the data types, like the same that we saw earlier. This is the D type, like when I was making the D type, and I recently saw like a post from Philip about using name tuples. So why the name tuples are good. So these are good for like doing small abstractions if you don't want to use the index-based sorting or getting things access. So I use name tuples. So I'm giving name as like short, NumPy, and C type. Because that's what NumPy even does in the original source code, but they call it something else for the NumPy one, so I couldn't figure that thing out. And the item size is like how big the item size is. So if you see 1, so it's like an I1, so it's like, oh, it just takes 1 byte. So offset, it's just for moving things along. And we start with 0 because right now we don't have anything in our memory, so we just go with 0 just to see things. So that's just the part 1. So part 2 is the memory management, okay? We have defined all the stuff that we need to work the whole arrangement. Any questions so far in this? Okay. So in memory management, like, this is the basic chunk of code. So, and coming back, so memory is super, super important. If I'm saying, oh, I'm building something like NumPy, I just want to preface that, it kind of follows the NumPy APIs more properly, as in it does considers memory to be very important. It's not like I'm spawning 100 different lists and tuples and everything and not using them. I don't want to do that. So memory was super, super important for me in here. Now, what I do is like, if there's no buffer, like we'll create a new buffer, okay? And it's just a dumb empty object for now. But next, what I do is, if I see there's a buffer, or like if there's a memory allocated already somewhere, I would use it. I don't want to just create 100 instances of buffer object for no reason. And finally, if there are multiple buffers, we just use them sparingly, like who is going to use what, you decide, and you get your stuff done. That's it. Part 3 is about the memory allocation. So what I do in memory allocation is basically I calculate how much actual memory you are going to need. So I say, oh, you're going to jump this much space, right? So this much space, the offset, and you get some values from the calculation. So if I say I want 100 objects, so it would be 100 objects and like the padding the offset has. So this will give you total number of memory you need, and this will tell you how much or what type of memory you need. So for floats, you would have like maybe like a byte, and you say like I want 5 objects, so you would get like 5 float object size instances. And again, it's the same check. This is a little redundant, but like, I couldn't figure out a good way of doing this thing in just one if loop. So like if conditional check. So it was like if there's num buffer provided, let's create a new buffer now. Here we didn't create a buffer, but like we just check if the buffer exists or not. Here we just check if the buffer is there or not. But here we actually create the buffer. So if you check, now let's create a buffer object. And what the buffer object is, I'll just show it. So if the buffer object exists, I'll use the C types array, because if I want to express a contiguous block of memory, so the best thing I can use is an array. And in Python, we have the array module, but I honestly couldn't understand how it works. I tried reading the docs, I couldn't figure that thing out. So I was like, oh, since I'm using C types, might as well cheat a little bit. So start using C arrays in this case. And it was pretty fancy, I'm not going to lie. But I couldn't understand shit here because it was super complicated and I was not able to understand. I read this one blog from 2020. I don't know what this guy was doing during the pandemic, but he did a really phenomenal job writing this blog. It's amazing. You guys should definitely check it out. But it was still like, going over my head. So I copied one line from his code and like just put it in. I have no idea how it works, but it works, okay? So it works. So TLDS, so we did the memory setup. We haven't created any arrays or anything. We just set up our memory storage. If you don't have external memory buffer or like, the memory block, we create one. We always give enough memory, the amount of memory we need for our chunks, like, that's it. And if we have something, we allocate it properly. If we don't have it, we create. And if we don't need it, we kind of, since it's a reference, right? So it kind of releases that thing automatically. Oh, okay. Yeah, question.
Are the external buffers like laid out within each instance of the ND array?
Oh, yeah.
Or is that like, okay, yeah.
Yeah, so every time, once you create a new ND array instance, it will create a new buffer. But like, for example, if you try to do one ND array and if you give another ND array, so now you have two ND arrays now. So there are two buffers. So in that case, it kind of checks, do I have reference of first one, or like, do I have the existing buffer somewhere that I can use to allocate my memory somewhere? So it will do that thing. So what more I can do with this thing? So, and this is where I just want to show a couple of things. I'm sorry, and just let me know if you guys can see. Is this big enough?
Yeah.
I mean, you guys at front, you can see, like, what are you guys?
No, there's
Okay.
a screen here.
Okay, so, all right, so let me just, okay, so here, okay, so this is the code.py. I just called code.py. I don't know why, it's just like, sounds good. So, C types. Okay, you can see, right? Like if you have, just let me know. And from, so here, I'm just going to create the same D type object so that I showed you in the slide. D type, D type was that short NumPy and C types. And I'll just create, like, I want to create bool. So D type, I'll call it B1. That's the way NumPy calls it internally. So that's a short name for this one. NumPy name is bool, and C type is C types the C underscore bool. So these are the some APIs that kind of figure that thing out. I'll make some more. Jesus Christ. I'll just make float. So 432. This is int 32, int 16, and int. So I create a bunch of D types now. Okay, so you can create as many as you want, like in what you have in the NumPy suite. So they have uint, int32s, like in a floats, and like long, half, and all the things. You can build that thing. So just to make things quicker, just add. So this is the ND array class. So what I was talking about. So it's kind of long, so that's why I'm just copy pasting it. So just to keep things quicker. So it's the same thing. It's the same code, but like now kind of defining none and like some parameters. Yeah. I'll show you what happens if you just go with this one. So if I create like an ND array object now, because I can't create NumPy arrays directly because we haven't added the functionality yet. So what I can do is, like, if you remember, it takes shapes and data types as the main object. So I'll say, I want to make an array of 2 by 3 size and a shape of like, data type of, let's say, int32. We'll do this. Oh, okay, hang on. That's fine. You know what I'll do? If I say like I'm going to follow pip8 properly, but like, screw that now. I'll just import star. Let's have pip8 like some respect. So. Okay, so if I do this, that's a problem, In Python, we can't see objects. If we define them, we can't see them properly unless we add the wrapper, stir, whatever you want to add that thing. So let's add that one. So you go back here and the wrapper code. So I kind of go and teach a lot of people Python about sometimes. So what I've seen is this one thing, this literally like, this piece of wrapper, it's one of the most stupidest things that, a person can write. But this took me more than 2 weeks to come up with, because it seems so simple, like, it's a wrapper, how hard it can be. Oh, you just have to wrap your object in that thing. So no, it's not hard, it's freaking hard. It's super hard that I wanted to see how I can have my wrapper show exactly the same output like what NumPy does, because that was the acceptance criterion, if you remember. It should match one-to-one to what NumPy does. And they were so hard. So I had to come with an intermediate small function to get something done. Oh, takes an axis, offsets, and all this. And these are like little boring topics. Okay, I'm not going to go into that one. And finally, I was like, let's make a wrapper. So it's like, if you see an object properly, if you see that, this is configured properly, and if it's of these particular types, data types, so what NumPy does is like for float 32, int32, and bool, it doesn't print the data type. So this is how you get that thing. And if I show you this one, if I do this, it kind of prints the output properly now. And this is stupid, honestly. I'm not going to lie. I've not done anything fancy here. But this thing literally took more than 2 weeks, okay? I have finished work sprints in that time. But I couldn't print out a simple wrapper, and that was like a pain in the butt for me. So, and if you want to do anything fancy, you can just go, how would I do, let's say, 3 by 4? Oh, let's just 3 by 1, that's simple. Oh, it should work in that way too. And it seems quite easy, but if you can do that, please let me know, because I would definitely like to have that code optimized, because I was showing it to one of my students and they're like, I hope that's not an assignment. I was like, no, because even I couldn't do that thing properly. So I was like, I'm not going to do that. So I had this thing. Now, but like, unfortunately, this can't do anything. Let's say if I make, let's say I have this one. So that's A. Let's make B. I have A, I have B. What if I want to add them? Oh, I cannot add that. Oh, you need to have the add operator supported here. Oh, that's another pain in the butt. So let's do that one. But now, okay, what if I want to give my own arrays like specific objects? Now I'm just defining 3, 1, and it automatically initializes to 0, 0, 0, because that's what default C types does. Is like if you don't find any values, just go with 0. So that's the 0-based indexing command. But what I can do here is, let's go with that one. So I'll just show you how I did that one. So it's item, and what else add? Okay, let me add this one. So we will add A and B. So this was B, and this was A. And now when I do A plus B, it still gives me 0, because I'm not cheating. It actually does that thing. Okay, but I'll just show you. So if I have, so here if you see, it takes 3, 1. So it's like 3 times 1 is like 3 elements. So if I say that, I just want to give you 3 objects. So let's say range of 3. Do that. It gives 1, 2, 3. Okay. So if I do the same thing with B, let me just do this, B colon. Let's say I want to give you 2, 4, and 7. Just be aware, like we have to give int because we define them to be int, right? So you can't give floats or anything, can't go fancy. So if we do, so now we have A as this, we have B as this, and if we add them, you get the arithmetic operation. So you're able to do arithmetic operations now. So that was the whole thing of this one. Okay, how can I add these features, like, so this is just add, normal add, but I have to do subtraction, multiplication, flow division, the trunk division, matrix multiplication. So there's so many fancy operations I have to do. So I wrote a code for that thing. It's similar to what add does, but it does broadcasting and every single stuff. So that's there. And now coming back to the slides, I hope that makes sense. If I have any questions, just let me know. So, but the implementation is kind of left to the reader because that's a little cheeky thing that I do. Now coming back to NumPy. So NumPy has some superpowers, like, it has a lot of things, but if I want to say what NumPy does pretty good that Python by itself can't do, is other Python list tuples can't do, is broadcasting, reshaping, and fancy slicing. That's something I'll call that. So broadcasting is like, if you guys don't know, broadcasting means you stretch the smaller array to match the bigger array, okay? So let's say we have this loop. So here, if you see, it's 2 by 3, and that's 1 by 3. So you can't have any arithmetic that just Python can't do. Okay, you can't just add them together. What NumPy does is, like, when you add them, it does this thing, okay, which is basically take the first element of both the arrays, second, third, and do the same thing, but for different axes or like different dimensions, and do the same thing and you get an answer, okay? So that's broadcasting, that's happening. So here, what NumPy did was it kind of expanded the array B to match the size of array A. So that's the thing that's happening under the hood. So in broadcasting follow 3 main rules. So if the 2 arrays of same size, or like same size, same shape, they would do whatever they want to do. So end of story, don't have to do anything else. If the dimensions don't match, then you work with the smaller array. So, you expand that thing. And when you expand it, like, you expand from the left-hand side. So these are like core principles that you have to do. And this is important because that's how the implementation also has been written in NumPy and in xsNumPy, that you have to switch, you have to work from left to right and everything. So now, second is reshaping. Honestly, I was asking one of my students. Okay, question.
So is broadcasting like a standard, or is it like NumPy specific?
Oh, it's a general mathematics standard. So it's like, it's a mathematical rule.
Matrix algebra.
Matrix algebra, yeah. So you just have to follow, adhere to that pattern. So
it's called in math. I know what broadcasting is there specific. Just also called the same thing in matrix.
I think so, yeah. Because, like, when I was reading through the paper, it was just broadcasting. or we broadcasted it to this particular dimensions or something.
Okay.
So the funny thing about the reshaping is I was explaining it to one of my students, and they couldn't understand what I was saying, okay, because the way I explained was shit, so that was super bad. And I showed them, okay, this is what reshaping does. I was like, okay, I get it. So it's basically, this is the definition from one of my students. So what this says was, it's like taking a pile of Lego bricks and arranging them in a new shape, but like keeping the number of bricks the same. I was like, oh, that's a fancy thing. You should be teaching me this thing, bro. But, okay, anyways, the whole point, and this is my thing on top of that. So arrays must have total number of elements, that's it. I don't care about like the shape or size, okay? So if you have like an element of 1 to 8 here, if you say, oh, I want to reshape it to be 2, 4, what happens is it keeps the same number of values, but it just changes how it looks. So that's reshaping. We kind of reshaping or changing the arrangement. So if I want to do this here, so I can do something like, I can add the reshape stuff. And now let's say if I have B, okay, let's take 4. And so it's 3, 4, so it's like 3 times 4, that's like what, 12? I can take 12 values, so I can give 12 values here. I'll just do a list of 12. Okay, this is the 12 values. So 3 times 4, and when I do a.reshape, and if I say, what is something that you guys want to see, like how it can do? Any suggestions? 6. Okay, 6, 2. Let's go with that one. So 6, 2. So it would do that one. So basically, kind of changes how the array should look like. But if you see, there's still 12 elements. So that's the whole concept of reshaping. You don't change the number of elements, but you just change the arrangement, how it looks like. So, and finally, so that's fancy slicing. That's something I call it. So everyone here is aware of slicing. So, Python lists, tuples, they kind of do that. You can use set item, get item to override the slicing behavior. So NumPy has this thing, Python has this thing, so we all know this one. So, like traditionally, like how NumPy or like Python does it. But NumPy does something like, a nested indexing. So I don't think Python can do it. At least natively can't do that thing. Here I'm just saying I want to select elements at like index 0, 3, and 6th position, and I get those values out. Another if it's a multi-dimensional array, if I want to do something like this is called as multi-index slicing because there are 2 levels of slicing. It's like row and column. So this is simple enough possible in Python, like in pure Python. You can't just do that. So, and if you have seen this pattern, so that's used in pandas, TensorFlow, PyTorch tensors and everything. So it's kind of the same construct. So here I'm telling, just pick the rows 0 and 2, index 0 and 2, and take the whole column. And it gives you those values out. So this is that was my biggest problem. Like, oh, these are the functions I want to do. Like, can I build those functionalities in xsNumPy? Because I know that they're kind of not possible just using Python. And I cannot do them without going mad. And are they crazy, overwhelming? I was like, yeah, it is. It was nutty. But I hope this all features, they do the same thing. So if we have B of what? Let's add one thing. I'm tired of writing that much stuff, so I'll just add an array object here. So array object is basically, I'm wrapping ND array here. So I'm telling, oh, just make a list of all these elements. So that's the contiguous memory, and put them in this thing. So what I was showing you before, the same thing here. So go to here. And if I want to create an array now, I can say I want to create an array of for, to close this. And now I have the array of like, this element. So if I want to index those things, if I say, oh, that makes no sense. Oh, let's do one thing. I want to have the whole row, but only the first column. Oh, it broke. Maybe I haven't added a functionality yet. So that is for the reader. So, okay, and that was intentional. I just want to show that there are a lot of missing pieces that can't be done properly just using pure NumPy and just using pure Python. So that is still like, there's an asterisk here. So what is next? What I can do with this thing? So everything else, if you understand the basic concepts, how to do that thing, you can do everything what NumPy does. If you use ChatGPT or something, you can get something around, but I don't recommend that one. But that's possible. So you can add numpy.add and everything. These are some features I've already added in the xsNumPy library. That's there. And now the finale of the whole movie here. So these are the key takeaways. So what I've learned is NumPy is amazing. So now I was just using import NumPy as NP all the time. Like, and I don't even care what's happening behind this. And if, when I'm not using it, I'm just using, import NumPy as NP and that's it. But it's amazing what the people at the NumPy dev team have done. It's amazing. It is super, super fast because it doesn't do the stupid dumb loops that I've written. So, if you can optimize it, definitely go ahead. And what I've done here is barely scratch the surface, like what's possible just using normal Python. And like, libraries like NumPy, they are kind of so massive that there's so many moving pieces. So it's not easy to implement a lot of things. But it's good to know that, you can still do something. I just want to finally appreciate the work, what the NumPy dev team has done. If there's something that excites you, go ahead, if you fancy this project, you can check it out on GitHub. I'm always looking for PRs and stuff. There's some references that kind of use a lot while writing this talk and while writing xsNumPy. There are related talks. So in 2015 from Jake Van so there was about how NumPy loops things. It's an amazing talk. And this was a recent 2024 talk from PyCon Japan about creating your own NumPy, but that's in C, C++. I was like, I want to do that in Python. And yeah, thank you. I hope that was any questions? Okay.
So okay. I know you mentioned this was a learning experience, but what do you see some use cases of it? I know having a NumPy implementation without C is pretty cool. So I was wondering
to be honest, I would say NumPy implementation without C is useless, but it's good for teaching. Because the whole thing is I want to be a teacher, so what I write is I want to write so that I can give these experiments to the students, Everyone said, I know Python. I was like, really? Do this, okay? Because I'm not saying I know Python too much, but I'm saying I was struggling. If you can do much better job, I would like to have that piece of code added somewhere here. So, and everyone is like, Python's quite easy. I want to learn C++. I want to do Rust. I was like, Python is easy to learn, but it's difficult to master. It's not just Python, but every language, in my opinion. So the whole point was writing this talk, or this tool was, how can I learn from my experiences as a software engineer and what I can do with it? And I've used NumPy pretty much. Most of my software engineering career, I have no idea how much it takes to understand it properly. So I hope that answers your question.
Have you struggled with the fact that NumPy puts a lot of stuff into every object? How do you handle this in your code development?
So honestly, for me, it was what NumPy does is so that's where the what's that? The JIT compiler, NumPy, and all those things are coming in for the matter. We'll just do the processing when we need it. But NumPy currently, from my understanding from the code structure that I've seen, is it creates a lot of storage, but it uses it quite I would say it uses it properly, efficiently. And I was trying to implement that thing, but I couldn't get that far. I'm not that smart, so yeah, I'm sorry. Yeah.
Yeah, for that So, I don't know if this is correct. So it's like NumPy, like basically a lot of, and like from your talk, these are like vector
Yeah,
operations
correct.
abstracted for Python, right?
Yeah.
Okay. Thanks.
How fast is it?
Performance-wise, it is good. It's like on par what NumPy can do because like I didn't time it properly, honestly. So that's why it's good enough. But I'm working on one more project, so that's called Slow Torch. So that's slow version of PyTorch. Again, PyTorch, but in Python. And in that, I have seen an abysmal performance, okay? And it's based on the same NumPy architecture, but like I wrote everything from scratch, but for PyTorch tensors and stuff. And it's horrible. The performance is super, super bad.
You mentioned Numba. Have you tried Numba on this?
No, but like the restriction is like I cannot use any libraries. So if I want to cheat, I would definitely use NumPy. Yeah, someone had a question? Oh yeah.
Okay, pedagogically, I think, like, is there a route where like the next generation of ML engineers are touching C++ and C like less and less and less, and sort of like where do you think this as a pedagogical exercise fits in the current landscape of what the industry needs from ML engineers?
So okay, so from the teaching perspective, I would say this is just a tool if you want to get into software engineering, but not in machine learning, because for machine learning you can subscribe to the Slow Torch API. So because that does machine learning stuff, so linear algebra and like matrix multiplication, all those stuff. But for NumPy, what NumPy does is, or the xsNumPy tries to do, it just implement the core software engineering principles, recursions, loops, operator overloading, class implementations, like inheritance and all those stuff. How I can do that thing, that is good for like if I want to teach students software engineering, how to implement those simple features. This is a good way to do that, but I would not use this for machine learning tools or anything. But this is for software engineering and math. Like if I want to explain what vector arithmetic is, this is a good way of explaining that, because I learned a lot of things when I was doing this one. So, yeah. Okay, any questions? Okay, one more, okay.
At what point were you like, at some point, I'm sure like a lot of points you were like, oh, I just want to use this other library or whatnot. Like for especially this Slow Torch or this one.
I'm sorry, I couldn't hear you. What?
Like, so like for those, like when you want to use another library, is there at any point that you had any wiggle room? Like, or you always started from like, I'm not doing anything from scratch?
No, for me, it's like, I want to do things from scratch. Yeah. Now, because the thing is, I don't consider myself to be a minimalist, but I don't want to install 100 different things. And the problem is, sometimes it's not coming from at Microsoft, when I was working at Microsoft, the problem was we're installing some packages and 2 versions deep, like they are not supported now, or like it's deprecated, or like it's kind of old. Sometimes as Colin said, like containers, like that's good for like having the same, or it works on my machine. That's good, but like not everyone is sharing your same environment. So that was the biggest problem. And from that moment, I decided if I'm to write something, try to implement things from scratch as much as possible, or like using the standard libraries which work across the board on every system. But if it's something that I cannot control, like if I'm writing a machine learning model, if I want to use PyTorch or TensorFlow, then I would just pin dependence in and use those particular subsets of those APIs. But if I can do something from scratch, I would definitely write it from scratch, because I want to have complete control how the output looks like, what happens when something fails. If I want to send an email from a logging system or something like that, I want to have complete control for that one. Yeah.
So this with the PyTorch, like, for example, like, can you write using PyTorch to doesn't it use like the shared memory space?
Yeah.
So can you write with using your implementation that read it from a different implementation?
I tried, okay, I'm not gonna lie. I tried to do the same thing with NumPy also, but like I couldn't understand how it works, because I wanted to do something like in NumPy or like in PyTorch, it's like there's an option to do tensor.from NumPy or like from from string objects or something, and I couldn't figure that thing out how to do that. So, but if I want to do something like, I'm not working on xsNumPy now, but if I want to come back, this is something I'll definitely do, like, how I can join this with the traditional NumPy so that it kind of uses the same APIs. And funny enough, like when I was writing test cases, I couldn't figure things out and everything was passing. So I was like, oh, my code is pretty good. Turns out like I was testing with just NumPy and that's why everything was passing. And now I was like, oh, okay, shit, like it doesn't work that way. So, but yeah, I would say that would be the next step in my this xsNumPy journey. Yeah. Any questions? Okay.